Hello, everyone, and welcome to another very special Nelson's Corner. This is Christmas holiday bonus number 2 with your host, Mr. Nelson LeKay. Hey, Nelson.
Hey.
Hey. Also joining us as the student, for real, but he's getting there, Mr. Zach.
Hey, how's it going?
Zach Parrish.
That was the best echo ever.
Thank you.
That's awesome.
Myself, Jason Busby, which kind of gets to play on both sides of the fence. Yeah, so anyways, I'll help with stuff from time to time, and then I'll help ask questions from time to time if Zach just may not have realized that there's a good question that needs to be asked.
Sure.
But this video, I do believe Nelson is going to, again, it's a bonus video, and a lot of stuff that's going to be excellent for Zach, but it's a video on working with expressions, and there's a lot of stuff that Nelson is wanting to cover to get some stuff that would normally look pretty crazy to Zach up on the screen, but start getting Zach much more comfortable at looking at code like this. I'm not going to exactly say how Nelson defined Zach's feeling at, currently when he looks at things like that's found on lines 45, 6, and 47 there. But needless to say, what's that?
I was indented improperly. I just realized. Usually this.
But anyway, so that is the objective. Again, it's just a bonus video for those of you that are relatively new to working with expressions or only comfortable working with very simple expressions. There's a lot of neat things that Nelson would like to talk about. And so again, it's just a bonus video for our member sponsors. And with that, Nelson, take it away.
Yeah, well, I like expressions. And expressions are anything in a language that evaluates into a value. So you see how main returns void, right?
I do.
Main doesn't return any value, doesn't evaluate into anything, and the same thing goes for right line. Right line returns void. But everything that goes in here is an expression, and you can pretty much do anything with an expression. You can do conditionals with an expression using the ternary or null coalescence. You can initialize objects with an expression using the object array initializer or the object property initializer. You can invoke methods like you see right here. I'm invoking the string.join and then the enumerable.repeat and then the select and so on. And being able to read expressions and be able to write them will significantly decrease the amount of code you have to write. And it's not something that you would generally see in a more beginner-oriented thing, and I think that's also why it's not. You don't. I don't know. There's this weird perception that writing long expressions leads to code being unreadable, but the funny thing about it is once you know how to read it, it's considerably more readable because your intent is better expressed in a way that's more compact than if I were to break, for example, these few lines into their corresponding statements.
Right. It's not that it's unreadable. It's just that you can't read it.
Yeah.
I see where you're going.
It's terrible, elitist sounding thing to say. I know, but it will allow you to write code faster.
It doesn't make it any less true. I mean, It's one of those things where it's like once you understand, even with a foreign language, once you understand that language, then you can read it. Until you understand that language, then it's just a bunch of gibberish. Right. And it's kind of the same thing. I mean, if somebody handed me something that was written in Italian, I mean, I might get a couple of words of it, but I don't really have any idea what's being said because I don't speak Italian. I don't read Italian. If I study it and come back, then suddenly, this all makes perfect sense. It's the same thing.
It's no different than when we were working on the MMO tech, and I was showing Lee some of the very, very helpful link statements that I was using, and Lee simply looking at it and saying, "Man, that's just so unreadable."
Right.
How am I supposed to go back and work with this because I don't know what it's saying, and that's the point. He didn't understand it.
Yeah.
Because understanding it, I looked at the code and looked back at him and said, "Are you crazy? It's very straightforward. It's right there."
Right.
But yeah. So, anyways, it's just a matter of understanding.
Right, and something that you'll have to kind of develop as you start reading more complicated expressions is you have to keep a lot of things in mind. Because, like, for example, if I were to read this, if I were just looking at this for the first time, I would start with this string.format. I would realize that something is being formatted in this way, and oh look, there's a name and a first name and a last name, and that's being selected out of the enumerable.repeat method, which I already know about as part of the methods that come with link. Basically just takes whatever this value is and repeats it this many times and returns an enumerable of that length. And then so we're selecting everything in this enumeration, and then we're transforming it into this string, and then we're joining it with this, and then we're writing it to the console. So you kind of have to read it backwards and know sort of what it's doing at every step and keeping those steps in mind. I have really, really, really weird conventions when it comes to expressions. I haven't really solidified anything. You'll see, like, on my string methods, I usually break them out. My ternaries, I break apart. My null coalescence usually on one line. It's all about context and what looks readable to me at the time, I guess. But, yeah. So, what do you know about the ternary?
Me? Seriously?
Yes.
Nothing. Go ahead.
Okay, well, the reason it's called the ternary is that every operator in a language, in any language, is unary, binary, or ternary. And unary operators, such as the most worthless operator in existence, the plus operator, which I just found out about when I was reading through the specification, is this literally is valid code that just returns 10. It does absolutely nothing. But that's an example of a unary operator. And then also, if we were to do not Boolean, that's another unary operator. Then we have binary operators, which take two operands. Like, for example, the plus operator is a binary operator because it takes two operands, a left and a right, and combines them. And then we have the ternary. And the reason it's called the ternary is because it's the only one in, well, any language that I know about. I'm trying to think if I've heard of it called something else. In Cold Fusion, it's the IIF function. But I don't even want to talk. Anyway, so yeah. So the ternary operator is how you work with conditional branching in an expression. So, for example, if I were to say, hey there equals 10, and I want to say, I don't know, name equals. I want to make this name say one name if hey there is less than 5, and another name if it's greater than 5. So I do that with starting with an expression. So I write an expression. Mm-hmm. This could be an expression of any length. And then I do the question mark operator, which is the beginning of the ternary. It's one of the two symbols. And then I write another expression. So this is an expression of any length. And that's important to know that's an expression of any length, because an expression is an expression is an expression. If this, what goes here is an expression, I could literally dump, this entire code into that one little space, mm-hmm. and it would still be valid. And then the second part of the ternary is the other operator, I guess you could say. And then the other operator after it has another expression. And then you can terminate it. And I don't know why I did that, because this is an expression. It's a Boolean expression, sorry. Meaning it has to evaluate into a Boolean, just like an if statement.
Yep. And so your question mark kind of equates to true and your colon equates to false? Is that what I'm getting out of that?
Yes. Okay. So if this expression is true, if, for example, true is an expression that evaluates into a Boolean, obviously. If that is true, then do this, otherwise do that. It's also important to know that if this is true, what am I doing? If this is true, this statement or this expression never gets evaluated. So if I had something like delete all tables in database, which you should never do, then that would never be executed if this were true.
Right.
So does the ternary kind of make sense?
Yeah, it's fine.
Okay, so the next one is the null coalescence, and it's really just a compact ternary. If I were to go ahead and define a string, and this is a string that is not null, and I were to say, actually, I'm going to do something different. I'm going to do console.writeLine, and inside of my writeLine, I'm going to have a ternary. So if it's null, then, or hold on, I'm getting confusing myself here. If it's null, then return that. If it's not null, then return itself. Which I should probably swap it because it'd make more sense. So this reads as if this variable is null or not null, then return the variable. Otherwise, return the default value, I guess you could say.
Sure.
Now, the problem with this syntax, and the reason the no coalescence operator was really invented, was what if this is a huge expression? What if this is an expression that looks like this, and it could possibly evaluate to null? You don't want to repeat that twice. And even here, there's a lot of stuff that can be inferred by the compiler, and it does that by introducing the no coalescence operator, which is a binary operator, and it's literally just the value, which has to be a reference type, by the way, because this basically says if this is null, and only reference types can be null.
Mm-hmm.
So if this is not null, return this; otherwise, return that, and that's what those two little question marks mean.
Gotcha. And we actually took a look at this. Was it with the singleton?
Yeah. We use that to compact some code.
Okay, cool.
Well, those are the really two big building blocks, I guess you could say, of being able to write more intelligent expressions, because now we can, predicate on some arbitrary expression and go to two different branches if we need to.
Well, they're easy enough to understand out of the gate, so let's do something with them.
Yeah.
Or I could derail your train. What did you have in mind?
Well, I'm trying to think of using them in a practical example here, and I'm having difficulty.
Well, that's fine. I mean, all I was getting at was that the null coalescence operator and the ternary operator were both pretty easy to understand. So what's next?
There we go. There's an example of a ternary. So basically now I'm saying that if the last name is Nelson, then print something else, otherwise print that.
Gotcha.
So it's not a practical example, but...
No, but it gets the point across.
Okay. Property initialization, which we can't do on our classes because they're all immutable. Well, they're not immutable, but they contain private state. Let me go ahead and build a nasty imperative stateful.
At least it's not scornful. Jeez.
I don't know. What should I give this? I don't know. Window.
For anyone that's watching this video without having first seen bonus number 1, just want to point out that this code did not just magically appear. This is the result of the bonus number 1 video.
Yeah, it's probably worth mentioning.
Okay, so there's a nasty way that we can initialize this, which is... Okay, there is, and I think this is something that we've gone over already, I think, just in passing, I guess, but there's a different way you can write this, and that's using the property initialization syntax.
Mm-hmm.
So that allows you to basically do brackets, terminate it, don't terminate that,
Thank you.
and then do all your properties and initialize them to something.
And
Sure.
just to point out, that's what ReSharper was.
Yeah,
Trying to
ReSharper will tell you when you're doing something dumb. It'll tell you to write it better. So that's the object initialization syntax, and the object initialization syntax is incredibly useful, especially when you want to work well with expressions. And an example would be, let's go ahead and go ahead and make a person record. And I'm just going to nuke all this code.
And
see,
be sure.
The thing about these are they're not huge game changers in how you write code, but well, I mean they are and they're not, in that they don't really, it's not like if you don't do it this way your code is going to be brittle and break. It's that if you save 3 seconds every time you initialize a object, you're going to be saving quite a bit of time.
Mm-hmm.
And so if we have like a person record with a first name, I'm really original with my stuff. This looks very familiar. And then X and Y no longer applies, so let's just do age. And then we have a persistent service. We can now do something like and then we can define our person record in a single line of code rather than going out and doing a bunch of other stuff.
Mm-hmm.
So we can give them a first name and so on. So yes, how do you feel about that?
Yeah, I feel good, but go ahead and finish off the example.
Well, what do you mean to this?
There you go.
Nice.
Okay. So yeah, so that's that and stuff.
Well, hang on. Well, how do you feel, Zach? Are you warm and tingly inside?
Oh man, the warmth, the tingliness, it's pretty incredible
okay,
right now.
just checking.
No, this has all been pretty easy so far.
Yeah. The other one is the array initialization syntax, which we've also seen. Actually, in the spirit of OOD.
Oh heavens.
So now we have our crazy braces everywhere. Now we have our array initialization, which initializes an array. So we can now do a bunch of stuff with, and so on.
Mm-hmm.
And then we can do a comma and, that basically just cut out an incredible amount of code that would have to be expressed otherwise if I hadn't used the collection initializer or the array initializer. Or the property initializer. Or actually, this is the array initializer. There's actually a collection initializer. See, you'll generally see me, I generally pass around IEnumerable. Have you noticed that a lot?
I've seen it, yes.
I don't really ever pass around lists or linked lists or stacks or dictionaries or anything because I find it really messy. Because then other people can get into your reference of your collection and start mutating it, and you generally never want that. So that's why I always expose myself as an IEnumerable. But you can also use the collection initializer syntax with lists if you wanted to. So if we went ahead and did equals new list, and then you remember the list from wherever, the list class.
Mm-hmm.
And now because list implements the iCollection interface, we can do this. We can do another sort of, it's similar to the array initializer syntax, except the difference is the array initializer syntax actually returns a new array, and arrays cannot be increased or decreased in size. The collection initializer syntax, when you use it on a new list or new anything that implements the iCollection interface, what it actually does behind the scenes is it calls the iCollection interface's .add method. So you're actually doing a different thing here. Every single one of these records turns in to a .add. And I can actually demonstrate that with Reflector, because Reflector is awesome, and we kind of neglected it in the last episode, near the end. get out of... So you see the, if I go into my person DB persistence and look at my get people, it still creates the individual records, but ultimately what it does is it returns an array.
Right.
Because we initialize a new array right there with 5 people in it, the amount of people I have, and then it sets each one of these individual records to a value in that array. Whereas with the collection initializer, we invoke the .add right there, and the .add right there. So we initialize our object and then invoke the .add method. So it's cool, though, because we can actually leverage that in our own code. Ew. All right, just ignore the rest of the members of iCollection. We're just focusing on the add right there.
Okay.
So if we go ahead and replace our new list person record with a new people bag,
Yeah.
we get an error because I missed a semi. We should see our person added because this method is being invoked on behalf of us by the C# compiler. There's also one more initialization syntax, and that's the dictionary initialization syntax. So do you know what a dictionary is, right?
Sure. It's just a. I mean, it's a list. Well, I can't say that, but that we come back to the whole conundrum of using words that make sense in the real world no longer making sense in the programming world.
Well, a dictionary is it's a key value pair.
Right.
That's a list of key value pairs. So we can do this. What the problem is that this is no longer valid, but we can do this. We can open up with a new brace, then close with the brace, and it's going to freak out on me. And then you put the key right here, comma, and then the value. And then we do it right there too, so key to value. And then we need a comma. And so that basically, it does the exact same thing as if I were to compile this and look back at the assembly. It does virtually the same. How do you just refresh an individual assembly? Did that do it? Whoa. Okay, so you see that it's going to go ahead and actually invoke the add method on this dictionary.
We'll just pretend like I didn't hit anything there. Keep going.
What did you not hit?
I did not hit F5.
Okay.
I just refreshed.
Oh, no. Yeah, I knew how to hit F5.
I know you did. I just wanted to hear you say "whoa." It would have just taken less time than. Anyways, continue.
Okay, so you see that with our dictionary, we do the same thing. We initialize our guys right down there, and then we add it using the add method. So, yeah. So those are the different kind of syntaxes, and I'm actually kind of embarrassed that I don't know off the top of my head what interface allows you to do this. Jason?
There you go.
It's probably... Oh, yeah, it's key value pair. Okay, so the key value pair must have some sort of magical initializer, or they just built in support for the dictionary. But, yeah, either way. Actually, I can't sleep at night if I don't know the answer to this. Let's see if we can replicate the same behavior by doing this. Doing an iCollection of key value pair, string person record, implement it. And let's see if our object, no, it doesn't. Okay, so it looks like this dictionary initialization syntax is only available on the dictionary class. So, It's kind of disappointing. But yeah, so that is object initialization. Do you have any questions, Zach?
No, not yet. I mean, that's initializing a lot of different types of things.
With less code.
Yeah. Now we're going into expressions now?
Yeah. How do you feel about talking about anonymous types, Jason?
That's fine with me.
Okay. So you want to see something that'll blow your mind, Zach?
Go for it.
I'm putting on the raincoat.
Okay, do you know why implicit typing was introduced to C#?
No, I don't know why.
It was introduced explicitly for this feature called anonymous types. So do you have any idea what's going on now?
Well, you're storing a new, but we don't even know what it is, that contains property which is set to value and an age which is set to 10.
Yep, and if we were to look at this guy, we see that he has two properties. Also, these are all immutable properties. You can't set them after they've been set.
Gotcha.
But this is completely valid C# code. We basically initialize a new object without defining a type. And that's where anonymous types come in. And I'm going to go ahead and rebuild. I didn't do that. Rebuild. Problems with the B key. It's probably hitting the N key.
I'd say it's probably not the B key is what I'm thinking.
Alright, and then let's go ahead and refresh. And you'll see something weird in our assembly. Well, you won't unless I move down to C# 2.
That was awesome.
Just refuses to... There we go. So our something gets initialized to a anonymous type 0 of type string int with value 10.
Hang on a second. Go ahead and pull it a little bit to the left. Zach's now looking closer at the screen.
You're good. You're good.
Okay.
Yeah.
Okay, so the C# compiler basically created us a nice little anonymous type that looks like this.
That has an age field and a property field.
Yes.
Cool. But it's not really anything specific. It's just kind of its own little nameless thing.
Yep. You can never reference this from your C# code. It's completely handled by the C# compiler.
Ah, gotcha.
The reason why they introduced anonymous types was for link. Okay. Well, okay, so you remember how we were talking about earlier where a link can be applied to databases?
Mm-hmm.
Well, anybody who knows SQL knows that sometimes you only want to select one or two properties out of a table.
Sure.
Right?
Yeah,
Instead of saying select star.
Sure.
So in order to handle this, link, we can now do, with anonymous types, we can now do something like this. So imagine this was actually coming from a database. We could do select, and then we can pass in a lambda, so it's going to be person goes into new anonymous type. Now, if we did this, also, if you're doing a property, you can actually just emit this, and the name is going to be inferred by the actual property type. So that's equivalent code. It's just another shorthand. It's like a shorthand of a shorthand, which pretty much describes C#. So you see, we're projecting these people into an anonymous type with a property of first name. So if we did people dot first dot, we now only have a first name. And now in this case, it doesn't really do anything because our person records still get instantiated, they still get turned into an array, they still get passed back, they still get looped over, and they still just get selected their first name out. But if we were working with the database, if we were working with the link provider given to us by an Hibernate or entity framework, it would be smart enough to figure out that the anonymous type we're projecting into only is asking for this one column, or is only asking for this one property. And it'll infer that and only generate SQL that grabs that one property. And so that's a case where anonymous types are very useful. I generally don't use them at all, except for in LINQ. If I have a very complicated query using the Fluent query syntax, like for example, if I were to do, let's say my objective right now is to return, get a dictionary of people by name where their first name is the key. I would do that by writing a Fluent query. Actually, I would do this in a different way, but I'm going to do it like this just to... I hate how it doesn't know what to do with invalid code. I would actually do this differently, but I'll just do this for a demonstration real fast. So now let's predicate on first name does not equal something. And let's just imagine that there's a lot of more complicated stuff that we do. And then at the end of it, we want to project it into a dictionary. So I'm going to select, but I don't want to select a person because actually no, I need a third factor here. Something external to people. Actually, this can get kind of philosophical right now, but hold on. Okay, fine. So let's say I wanted to do a people by name is a bad example, and the reason it's a bad example is that everything that we need on a person is available on a person. There's no reason to break it out into anonymous type.
Okay.
But occasionally you might do a query where you query on a bunch of different unrelated things, and then you want to combine a bunch of unrelated things into this one temporary object to use in the future. So let's do something crazy here. Let's do types by assembly. So from assembly in app domain dot current domain dot get assemblies. Select new assembly equals. Actually, generally when I do this, I just do key equals ASM, value equals ASM dot get exported types.
Of course you do.
Oh, I do this. I actually do this all the time. And then I'm going to do toDictionary on key and on value. So you see what I did there is as I broke apart. I'm going to break this apart actually. Is I broke apart a bunch of unrelated kind of things, and actually this is also kind of a bad example. I could have used the group by operator, but I guess this is just for demonstration. So I took two unrelated things and I projected them onto this anonymous type, and then I took the information from this anonymous type to construct a dictionary using the toDictionary method, or a LINQ method. And the toDictionary LINQ method wants two lambdas, one to project on a key and the other one to project on a value. So first we're selecting iterate over every single thing that was returned by this query being what's in these parentheses, and loop over everything that gets returned by this lambda set as a key, everything that gets returned by this lambda set as the value. And so now we can loop over it. And do something like this. Do that. Let's start breaking this out because this is actually going to get long. Let's have some fun. We want to write that, and then we want to write that. Probably do that. And the first one is going to be the assembly name. Actually, I'm doing this backwards. What am I doing? For each loops are bad, by the way. I don't like them. Okay, so console write line, and then so now we're going to construct a statement from, well, I guess the bottom up, or the top down, I should say. So we're writing something, and we're going to be writing a string. And that string is going to have the assembly name, And then underneath the assembly name, we're going to be putting a list of types. So we're going to do that, and then that. Then 0 is going to be the assembly name. So it's... hold on, I forgot to select. So we're going to be doing types by assembly select. Key value is... generally when I work with dictionaries, I do KV for key value, because that's the object they return as a key value pair if you were to enumerate over them.
Mm-hmm.
So KV, KV.key is going to be the assembly, so we're going to do, I don't know, fully qualified, or full name, sorry. And then the next one is going to be whatever goes in here, and whatever goes in there is going to be a string.join of a new line separated list of kv.value being an enumerable of types. Remember, value is set to asm.getExportedTypes, which are the types exported by this assembly. And then we're going to want to project that onto a string.format. Let's just do name with a dash, and so then t dot name. So now if we were to run this, we would get a bunch of stuff. And the reason we actually get that is because of an issue I always run into with string.join, and I hate it. It takes a param object array, but there's an... The issue is that it reads this entire thing as a single object being passed in. So it takes this single object and flattens it using its toString method.
Mm-hmm.
So what you have to do is you have to either you have to convert it into an array somehow, and you can do that with the toArray. Once we do the toArray, it actually resolves the assembly different, and we don't get what we expected. Because I probably did the toArray on the wrong thing. No. Did I not compile? Pretty sure I compiled. See anything, Jason?
No, I sure don't.
Well, toArray, string.join. Well, that should work. Trying an array of strings, maybe. No, there is an overload for an array of strings. So my parentheses will line up. String.format, assembly type name, kv. Oh, there are all my types. Anyway, I can take this this time. Generally, after I write something, I format it after I write something, or if I have to debug it for some reason, in which case I do this time. Yeah, it looks about right. Format. Oh, yeah, I don't know how I missed that. I don't know, it's getting late or something. Should have concated on this. My bad. There's all your assemblies and types.
Gotcha. Now that you have that working, I feel I should probably tell you that I don't have the first clue what you just did. But I didn't want to interrupt you while you were trying to get it working, because really it's like trying to explain what went wrong and what I don't understand about something that wasn't working in the first place. So now that you've got it working, what in the world did you just do? Just start at the top, work your way down. You started off with your variable types by assembly. Great. Move down from there.
Okay, from assembly in appdomain.currentDomain.getAssemblies.
Which I've never seen before, by the way.
The app domain, it's this thing that's created when your program launches. It's a container of sorts. One process, one running executable, can contain as many app domains as it wants, but code can only communicate with one app domain. So you can actually have code running in multiple app domains in the same process.
Yes.
So when I'm saying appdomain.currentDomain, I'm getting the currently executing domain. And then I'm asking that currently executing domain to give me all the assemblies that have been loaded into this executable. And, like, for example, you see all these assemblies over here, in addition to the assemblies that are added by C#, the compiler itself, by default. And then I'm looping over, I don't want to say looping over, I'm projecting onto this anonymous type with these two values, key and value, key being the assembly that I'm currently looking at, value being the exported types, and exported types are all the public types defined. And remember, types are anything that you can make a variable out of. So types are classes, structures, delegates, enumerations, interfaces. So that's getting all the types. And this is what's called reflection. It's the get exported types and the assembly type, which is what's returned by get assemblies. It returns an array of assemblies. It's part of the reflection API. And the reflection API lets us reflect on ourselves and actually introspect the code that's running. And it's really, really cool way to do a bunch of dynamic type programming. So we're looking at all the code that's currently loaded in this app domain, in this process. And then we're getting all of the types, all of the classes, interfaces, whatever, that are being exported. And then we're projecting that onto a dictionary, giving the assembly as the key and the list of exported types as the value.
Okay. So you were just using the whole get assemblies thing as a means to get access to something that you could list off?
Yes.
Okay.
And actually started this example really poorly. I wasn't thinking right. Too much. You guys put me under too much pressure.
We didn't put you under any pressure. I mean, I want to make sure that everybody's completely upfront on that right away.
No, I'm fine. I was joking. I was just saying I screwed up.
That's no problem. So take me through this just one more time. We start with our right line, and you've got a really nice expression here, which you've been kind enough to break down into multiple lines. Let's just walk through it real quick.
Okay, so we're going to write whatever this expression evaluates into. We're going to join a bunch of stuff by new lines. And what we're going to join is types by assembly.select. So we're taking types by assembly and we're projecting it onto something. And I said that a few times, and what that means is we're turning every single value inside this dictionary into something else. We're changing what it is. And what we're doing is we pass in a lambda right here.
Yeah.
So KV stands for key value, because when you enumerate over a dictionary, you get a key value pair object. So that's why I use the word KV right there. And then we're projecting it into a string.format. And the string.format has this format, and you've already been reading these before. The 0 is going to be replaced by kv.key.fullname. And remember that KV is the key value that we're currently looking at. The key property is the assembly we're currently looking at. And the full name is the full name of the assembly that we're currently looking at.
Okay.
So we're taking every single instance of our assembly, and we're getting the name out of it, and we're dumping it right there in that 0.
I think part of it was that you were leveraging a lot of this app domain, current domain.current get assembly stuff that I didn't know about, and you're using a lot of the integrated functionality along with that. And so trying to follow along with that while you were throwing in a bunch of things that I'd never seen before made it a little tricky to keep up with you.
Yeah, it was hard because I couldn't think of an example.
Sure, I understand now.
Convoluted enough to.
Right.
Okay, so then we're replacing this 1 with whatever this evaluates into. This being that. So this gets dumped into whatever 1 is. And what we're doing is we're doing another join on new line. So we're taking every single value that's dumped as a result of this expression and joining it by new line, meaning sticking a new line on the end of every one.
Yeah.
And this expression results in an array of strings. And we're doing KV. So remember, KV is the current key value pair that we're operating on. Dot value. Remember that value is the exported types of the current assembly.
Mm-hmm.
So all of the public classes, like for example, this isn't a public class, but if I were to make it a public class, it would be included.
Yeah.
But I can't because everything else isn't public. So then we're joining that on kv.value, and then we're projecting every single exported type onto a string.format. And the string.format just adds a little dash in front of a 0, which is replaced with the t.name.
Mm-hmm.
T being the current. See, now we're in 2 selects. We're in this select, which is selecting on T being the current type we're looking at. And then we're also selecting on this KV being the current key value pair that we're working on.
Mm-hmm.
So you see we're kind of nesting the selects.
Exactly.
And then the 2 array there, those guys are just there to get string.join to work properly.
All right. I mean, that's that makes it make a lot more sense. Again, a lot of... I didn't understand going in what it was we were trying to do.
Yeah, and well, me neither. I was just trying. you said bring up a sample of an expression.
Yeah.
I've been working with a lot of reflection recently in my job, and that's just the first thing that came to mind.
Well, I think, I mean, and this isn't, I guess you could just look at it as feedback, I suppose. I think I'd have stayed along with you a lot more easily if I had understood off the bat what appdomain.currentDomain.getAssemblies was actually going to do and what we had intended to do with that information. Like, if you'd given me a quick rundown of what appdomain current assemblies get assemblies actually, no, I'm sorry, appdomain current domain get assemblies does, and then said what we, our end result is we'd like to be able to print off a list of these values, digging through the key value pairs of each one, then I'd at least would have had an idea of where we were going. But because we kept throwing in all of these things that I'd never seen before with functionality tied into these things that I'd never seen before, I started to kind of fall back. But yeah, I'm with you now, and it's great.
All right, sweet. So yeah, so can you read this easier now, or does it still look like a blob of characters?
Yes, it is somewhere in between something readable and a blob of characters.
Okay.
It's kind of like, I mean, I guess we're back to the funny Italian example I mentioned earlier, because I actually know a little bit of Italian. So now when somebody hands me something that's written in Italian, I can pick out enough words to actually make out generally what's going on, but I can't read it fluently, and that's kind of where I feel like I am right now.
Okay. Jason?
Let's see. I'll play the. Let me play Zach.
Sure.
No, I don't understand what the hell you did. It's. I mean, I'm still kind of getting my head around assemblies and now you've just kind of lumped all of this together. Since you were really looking at, at these assemblies and then all of the public or exposed types inside, could you have done any kind of example that was something I could relate to? I for example, I know you've got a this Z drive that you've got stuff on, and could you have somehow gone in and grabbed out, like if you created some folders in here and then use that to create some type of collection with all of the folder names, and then of course we have all the file names, and then it would have been language that would have looked a little more familiar to me, and then walked through and shown the list of folders and the names under it using some of your real fancy expression stuff here.
Okay. You want me to go do that?
I'm playing the Zach role. Zach, I mean, I'll hand that over to you.
Yes, he wants you to go do that.
No, not necessarily. I'm just going to say it
yeah,
to you.
actually, sure. Yeah, why don't you show me how we could break that down?
Would that have put things in a language? Because he could make a couple folders and...
Well, at least I would understand the data we're starting off with.
So first off, I start with what I'm trying to do. In this case, the entire goal of what I'm trying to do is, well, right line. There's really no reason to...
Did you just get a little quieter, Nelson? Did you move your mic away or something?
No, I don't think so.
Okay.
All right, so we have console.writeLine. The next step is to get what we need to work with. So let's do file, or directory, sorry. This lag is killing me.
And Nelson, again, I almost have to come up with a special Zach voice. Can you start out by not having this as one of your fancy expressions so I can visualize it a little bit better, and then show us how we went from a more verbose use of code into something that's been condensed with your expressions?
No, you don't need a special Zach voice.
Is that good enough?
That worked. Let's not go into special Zach voices.
Incredibly boring code.
That's fine, Nelson, but it does.
But it shows how we get to where we're finally going.
Yeah.
See, I don't know. How would you write this in any simpler way? Maybe do this. I mean, I feel really. Hold on. There's the file name. I need to project it. See, I need to project into file infos, and I can do that in one line of code.
Yes, Nelson, but remember, I'm Zach number 2, and I have no clue what you're doing, but I understand some of the stuff you're writing right now. That's pretty straightforward. Just trying to help you out, Zach. I mean, is this a question that might help make some of this a little bit more apparent?
We'll shortly see.
Okay.
See, your sharper's going to yell at me this whole way through.
Let it. Don't type for 1 second, Nelson. I want to adjust your volume for some reason. Okay, now see if that helps any. You're good.
Okay.
Or at least it's clicking's louder.
Yeah.
Hold on. File info dot. What's the absolute guy again? Is that full name? Yeah. Gotta be careful with the word file. There we go. So those are some files, and I guess we could make it recursive too, if we wanted to. But do you think this demonstrates the point enough, Jason? Or do you want to?
Well, I see that you're listing off some files in the Z drive. By recursive, you mean show the contents of folders within that?
Yeah.
Yeah, I would say make it recursive.
No, why not?
Because I don't know how I would do this in any way other than an expression. Hold on.
But you know what the expression would be doing, right?
Yes.
Then you should know how to code it without the expression.
Give Nelson a lot of props. He does an awesome job of just being handed a complex
He does.
idea and quickly generating it into code.
Mm-hmm.
While recording. That's
the crazy thing.
That's the hard part. It's one thing to sit around on your computer and you're coding. It's another
to actually
when
do
you
it
have
while
the
folks are
pressure
watching.
there.
Yeah.
use link right here. That'll take a while. There we go.
Wow.
Is that more of what you're thinking? First line of every file?
Yeah, that's good.
Yeah, nice.
It's exciting. Okay, so do you understand what's going on?
Well, walk Zach through it.
Yeah, take me through what you just did, and then after you do that, you'll be able to show me how we can convert this all into an expression and do the same thing and have that expression make a whole lot more sense. It'll be great. I'm excited.
Okay. So we set file infos to get files of the Z drive. Get files is just a recursive function that takes a directory, calls directory.getFiles, which is a static method that returns a string array of fully qualified file names, meaning they include the directory path up to that file.
Right.
And then we get it,
I said
or
right.
the names.
You're good.
The names. Oh, it is the names. And this should have failed. I always forget that. I always forget if it's the names or the fully qualified thing. In this case, you just do path.combine directory on file. There we go. Because I guess file info is not going to throw an exception if it fails miserably. Anyway, so we get files, so files is now a string array. And then we get subdirectory. Subdirectory is now a string array. Same concept, get directories, returns names of subdirectories in the specified directory. Which means that we also have to do path.combine, which I'm now sort of wondering why my code even worked a second ago. Does it still work? It should still work. Yeah. Okay, so then we create our retval, new list of file info. This should actually be I don't think it has an add. Never mind. I'll just leave it like that. So then we loop over every single file in our files array. We add a new file info. Constructed from the file that we're currently iterating over. And then we loop over our subdirectories and add a range of all the files that are inside that subdirectory. And then we return retval.
Okay.
Add range takes the enumerable returned by this and appends each individual item to this linked list or this list.
Sure.
So yeah, so are you comfortable with at least the recursion of what's going on? Yeah. Okay, so now file infos is just a flat IEnumerable of file info of all the files in the Z drive, and then we loop over it. We create a temporary string. We set it to something because I guess we're doing things the long-winded way. We initialize a stream reader. We get the first line, and we start in first line, and then we write a bunch of stuff.
All right, you got me so far. So now we're going to do this whole thing again with an expression, yeah?
Yes.
Show me.
Well, get files still has to be recursive,
right?
Which means that it's going to ultimately be another method declaration. But I suppose the quickest way to write this...
I'd say we could leave the one method. Go ahead and create a new one.
Okay. So what I wanted is throwing an error. Hold on. I must have hit something. Oh, it's the same name. So I'll probably do something like directory.get files. I've actually never done this before in a single line of code, so I might be totally wrong with this, but get files directory.select. We want to project it into file infos of the file name. Remember, that's not, we have to actually do a path.combine here on directory, file. Then we want to union it on a select many, probably. Union it on a directory.get directories, directory.select many, directory get files to directory. And then we also have to do our path.combine there. Alrighty, so that should pretty much return the exact same thing. The difference is that this is actually going to be deferred executed, which is cool. Meaning it's only going to start actually executing on the code that we, or on the individual files that we need in the individual subdirectories. So if I replace it, it should work just as expected. Yep.
Nice.
So yeah, so do you kind of understand what's going on there?
I mean, sort of.
You still with us?
Yeah.
Oh, okay, I didn't know if you got up to go hammer a picture on the wall or something.
Yeah.
So Zach's got this look on his face like, what? Am I pretty close? Yeah, it's shaky ground. So go ahead and I'm trying to think of how to be Zach here. So walk me through this one now that you've got it written, so that I can see it all while you're talking through it. Go ahead and walk through get files 2.
Okay, so we first determine what exactly we want. We want files, file string or file names projected into file infos. So we start with getting all the files in the current directory. Getting all the files in the current directory, and this returns an IEnumerable of strings, or rather a string array. And then we project it into file infos like we just said we need to do, but this doesn't solve the problem of getting all the subdirectories. So then we have to union it, and union basically concatenates two IEnumerables.
Mm-hmm.
So does that...
Yeah.
So basically it's going to take the IEnumerable that is... Could you pause the video for a sec?
Yeah. Okay, and we're back after what to you guys was an instant pause start, but for us was, I don't know, maybe half an hour or so. So picking back up right where Nelson was a second ago, he was starting at line 105, going over our static get files 2 method and just reiterating what it does now that everything's been written out, so that you're not explaining while you were typing.
Mm-hmm.
Yeah, so, alright, so we got this second method here. It's functionally equivalent to the first method, though obviously the implementation is considerably different. So the first step is, well, we return. That's kind of an interesting thing, is generally when you think about things in terms of imperative language, you start by declaring variables and looping over them and performing conditionals and stuff like that. But when you start thinking about things in terms of expressions, you think about, well, what am I actually doing with this data? What am I doing with the value of whatever this expression evaluates into? And in this case, we're returning it because this method has a single expression.
Mm-hmm.
So then we go ahead and invoke the getFiles static method on the directory that was passed in.
Mm-hmm.
This guy just returns a string, or I kind of already went over this guy,
but continue on.
Yeah.
So we got a array of strings. All those strings are individual file names in this directory, and then we project. And remember that I think I've already reiterated this a few times, but I really like saying project when I'm talking about select, because we're really not. see, you can convert a for each loop into a link expression, but it's kind of a different thought process. At least for me, it is. Whereas before, I was thinking about looping over each one of these individual files. In this case, I'm actually going the opposite way. I'm projecting each one of these strings into a new value, and I'm using this lambda that I'm passing in, a func that returns a file info
Mm-hmm. And that's
to
where,
construct.
That's where you're combining the file name and its path.
Yeah, I'm using the path.combine. That's because get files returns just the file name and not the absolute path to the directory. So in order to actually construct a file info, I need the entire path. So that's why I combine it with the directory and then f being what was passed into the lambda.
Gotcha.
So after this guy, so as of right now, we have an expression that returns an IEnumerable that represents a file info projection, I guess you could say, of all the files in a directory. But we need to get the subdirectories of this directory as well. So we use union to concatenate. You can think about it just like string concatenation, where we concatenate this IEnumerable with a IEnumerable that's provided by the expression that we pass in to the union method. So that's going to be this guy right here. So it's the same sort of thing where we're calling get directories on directory with directory, the argument. And then this guy returns an array of strings that represents all the directory names that we're getting. Again, it's just the directory names, not the full path. And then we're doing .select many, and we haven't really gone over select many. It's generally known as the most powerful of all link operators because you can actually rewrite every single link operator with using select many. If you actually look at the theory behind this is called the collection monad. The select many is the only operator that really matters when you're talking about the monad. But that gets into kind of the theory of stuff. But I find that stuff sort of cool. But so the select many, you can think of it as taking the IEnumerable that is created with this lambda having a D or directory, and then we're projecting it onto a get files to method call, but we're taking this IEnumerable that's a result of this expression, and we're concatenating it repeatedly. We're aggregating it into a single IEnumerable that is then unioned onto the IEnumerable that happened as a result of our get files call. Does that kind of make sense?
So far, I mean, well enough, yeah.
You can kind of think of it like a loop within a loop sort of thing.
Yeah, and that's kind of what I'm getting out of it.
Yeah. So this next select many call, or the select many call, the expression that this lambda evaluates into is a method call to get files to, which is a recursive method call to our get files to method, and that we're passing in path.combine directory comma D, meaning we're combining the directory passed in with the directory that was got as a result of get directories. And then, it's a recursive method call, so it's now going to go into this directory. In this case, it's going to be, I think we only have one directory here, reflector. In this case, the next method call of get files is going to happen on this directory here.
You'll grab all those files.
Mm-hmm.
But if there was a folder in there, it would do the same thing, and it would just dig a level deeper.
Yep. And so we just keep on doing that. We're basically... it's just a different way of thinking, I guess, because we only have one expression here, and the expression is calling itself using a method construct. In a functional language, we would just define a function, but in this case, we have to define a method, obviously, because we're in C#. So do you see how this kind of got constructed?
I do.
What's really cool, though, since you did not kill out the get files method, you can just show by using this expression here how much
code you just saved.
Yeah, exactly. That's very nice.
Yeah.
Yeah, and the cool thing is we're avoiding the imperative constructs of for each, assigning mutable values to new objects and using temporary values and all that stuff that you just generally don't need as much of if you think of things in terms of expressions. Typically.
And we can call this, because this is a bonus video, so we can call this a primer to expressions where over time. I say we start out and do some sort of knowledge review coming up with Zach soon, and have Zach write some simple expressions using LINQ and lambdas, and see if we can slowly work them up to some more complex stuff. And by having him work through it, any of our other newer programmers out there can watch and probably pick up quite a bit from that as well. And we can just do that as another special kind of bonus video that goes on top of all of the actual Nelson corners that are focused on very specific topics. Sound good?
Sounds awesome.
That's one way to just make sure everybody really gets it.
Yeah, absolutely.
And for those that do get it, they can just skip knowledge review. 'Cause they get it.
Of course.
'Cause I know there are people out there right now that.
But there could be significant comedic value with me actually trying to type something out.
There could be, that's for sure. And Nelson, because his size are going to be ramped up.
Oh yeah, I'd be like, why did you just type that?
I can't believe you
come
did
through the
that.
monitor and stab you.
All right. Well, Nelson, is there anything else that you'd like to add?
No, I mean, other than we can similarly compress this down to a single statement, or expression, but I think that's probably best to do after some sort of review.
Okay. All right, Zach. Anything else?
No, I'm just I'm going to need some digestion time on this, I think.
Yeah, there's a lot of stuff tossed out there. Okay. Well, I'd like to thank all of our member sponsors, and of course Nelson for coming up with this stuff on the fly. I know it's extremely challenging, especially when you're on the spot, and it's not like you can say pause, unless somebody's beating on your door, but that's different. And Zach, thank you very much as well.
Thank you.
And that will wrap up this holiday special bonus number 2. Bye, everyone.